So what are addition reactions? Addition reactions are extremely important reactions and they are known as the chain growth reactions. Now, why they are called as chain growth? So there are three stages. The first is the stage of initiation. The second is the stage of propagation. And the third is the stage of termination. Clear? Now, each of these stages have their own use. The first stage, which is the initiation stage, in an addition reaction, what happens? First thing to remember, addition reaction occurs when there are unsaturated hydrocarbons. So what is the unsaturated hydrocarbon? Here is the unsaturated hydrocarbon. So unsaturated hydrocarbon, which is the ethane group, which is ethene group, C2H4 is the unsaturated hydrocarbon. On this, the addition reaction would occur. How? We have certain catalysts. Now, these catalysts, this could be benzoyl peroxide, it could be acetyl peroxide, it could be tert-butyl peroxide. Now, these peroxide or the catalysts which are present, they release the free radical. Now, which free radical? Since it is benzoyl peroxide, we have phenyl radical which is released. Now, this phenyl radical combines with ethene, which already has a double bond, as you can see here, since it's ethene, E. Now, this would break that down into a hydrocarbon with single bond. Okay, so this phenyl radical attaches to ethene and forms a reaction where you have just single bonds, no double bonds. This is where the process initiates and therefore we call it as the chain initiation. Now this chain would have to propagate. Now this, what is prepared with phenyl radical and ethene, combines with the next molecule of ethene. Now, when they combine with the next molecule of ethene, we have a chain that is formed. Now, when this chain continues, we would have a bigger chain with n number of polymers that are present, and our radical size would get bigger and bigger. Now, as the radical size gets bigger, the chain reaction would propagate. We call it as the chain propagating step. Now, in the final step, what happens? This propagation would stop. Either two of them with the same chain would come and join together. We call these as polyethene. Now, polyethene occurs when the free radicals combine together. Now, there can be homopolymers. For example, polyethene is a case of homopolymer. The same thing being joined again. The next is a case where butadiene is joined with styrene to form butadiene or butadiene-styrene copolymer. Now this is where copolymers have joined. Okay, it is again a polymerization reaction, but in the case of polyethene, it is homopolymer. Why homopolymer? Because the same chain is joined from both the ends. Okay, so C6H5, which is the phenyl free radical, comes on both the sides of the chain, and then you have a series of CH2 which combine together. So we call this as homopolymer or polyethene. However, when there are different monomer units, we have different functional groups, different monomer units. What would happen? Copolymers would be there, and therefore the reaction would form butadiene or butadiene-styrene copolymer. Clear? Now there are three important things that we would understand, or formations under addition reaction or chain reaction. The first is polyethene, then we have polytetrafluoroethane, which is Teflon, and polyacrylonitrile. Polythene is the common polythene bags which are used. So polythenes are either linear or they are slightly branched, so they have slight branching or are linear, and they can be actually heated, melted, got softened, resettled. Okay, so we call these as thermoplastics. Now this ethene can be of two types. It could be a low density polyethene or a high density polythene. Low density polythene is where the pressure is 1000 to 2000 atmospheres, temperature is 350 to 570 Kelvin, and what is the catalyst? Either dioxygen or peroxide is the catalyst. Now this is a highly branched structure, and sometimes they can also have chains. They are relatively chemically inert and flexible but are poor conductors of electricity. They are used for the process of insulation of electric wires as well. So if you have a copper wire running, onto the top of that copper wire you would have the flexible pipe which would be there, and this is what is polyethylene. The next is high density. High density has a very low atmospheric temperature pressure, which is 6 to 7 atmosphere, and temperature again is lower, 333 to 343 Kelvin. Now here what are the catalysts? The catalysts are triethyl aluminium and titanium tetrachloride. Now, titanium tetrachloride is also known as the Ziegler-Natta catalyst. So, these two catalysts are present as for the high density polyethylene. Now, high density polyethylene, which is also known as HDP, has usually linear molecules, and the density is high because of the packing. It is close-knit packing. Okay, and these polymers are also called as linear polymers. They occur in chain, and since they occur in chain, they are called as linear polymers. So these high density polymers are basically relatively hard. They are more tough, and they are used for making more stronger things. For example, this could be dustbins, this could be bottles, pipes, and therefore we use high density polyethylene there. So low density polyethylene is relatively soft and used for easier work. The next is Teflon. Tetrafluoroethane, n number of molecules join to form. So this double bond, unsaturated, would convert into saturated, as simple as that, and we call this as Teflon. Now Teflon is resistant to attack by the various corrosive agents. It is used for sealing the oil. It is used in gaskets and in non-stick cookwares. We also have the Teflon cookwares. The next is acrylonitrile. Now again the double bond changes into a single bond. We have a series of it which is known as polyacrylonitrile. All of them are same. So we call these as homopolymers again. Okay, polyacrylonitrile is a wonderful substitute for wool. So it is a good substitute for wool, and it is used for making the commercial fiber which is similar to wool, which is known as orlon or argilan. There is where we have polyacrylonitrile which is used. So in this section we have talked about the addition reaction. What is addition reaction? Why it is important? And the three important compounds that can be obtained, which is polythene, Teflon or polytetrafluoroethane and polyacrylonitrile, which are all the types of what? They are all types of addition reactions which can be seen, and all of these are monomer units. They are linear. They are not branched. They are not cyclic. They are linear. Very, very important to note.